Did you know that water isn't just a liquid, it's a shape-shifting molecule with 15 different kinds of ice? And that pouring boiling water literally sounds different than cold water? Or that in the 1700s, scientists called purified water dephlogisticated water? Strap in, because we're diving deep into the weird, wild, and surprisingly mysterious science of H2O. Before we dive in, just to let you know that we're seeing that 55% of our viewers who watch our channel regularly have not subscribed to us yet, so we're asking you a favor. Before we start our deep dive and you like us and also want to support us, there's a free and simple way to do that. Just hit that subscribe button so that you never miss out when we put out new videos, and we assure you that we will commit to bringing you the best videos each week. We also crave your feedback and suggestions as we aim to give the best. Now let's begin our feature presentation. Water looks simple, 2 hydrogen atoms, 1 oxygen, H2O. But this molecule defies the rules of chemistry. It expands when it freezes. Most substances shrink. It has an abnormally high boiling point. It can dissolve more substances than any other liquid on Earth. Why? One word: hydrogen bonds. When water molecules get close, the slightly positive hydrogen atoms of one molecule are attracted to the slightly negative oxygen atoms of another. These hydrogen bonds are temporary, but incredibly powerful. They're why water sticks to itself, climbs up plant roots, and can absorb so much heat. It's also why ice floats. Hydrogen bonds hold the molecules in a spacious hexagonal lattice, making ice less dense than liquid water. You've seen ice cubes in your drink. That's called ice, the ordinary ice. But water can form at least 15 different crystalline structures depending on temperature and pressure. Here are just a few. Ice 2, a denser form formed under high pressure. Ice 3, tetragonal, denser than ice IH. Ice V and VIX, found deep in the interiors of large icy moons like Ganymede. Ice 7, can exist at room temperature if you crank the pressure up to 30,000 times atmospheric pressure. It's even been found inside diamonds. Ice Type 1, a ferroelectric form of ice that has spontaneous electric polarization. Ice Carnitine, the least dense ice ever discovered. Scientists made it in 2014 by removing neon atoms from a special clathrate structure. Each type has a different atomic arrangement. Some are stable only in labs, others might exist on distant exoplanets. In total, science currently recognizes ice wine through Ice 15, and newer ones are still being discovered. So yes, water has polymorphs just like carbon has graphite and diamond. Ever notice that pouring boiling water sounds different than pouring cold water? That's not your imagination, it's physics. When water is boiling, it's still saturated with tiny bubbles of steam. These bubbles violently collapse when the water hits a cooler surface, creating a sharp, crackling or hissing sound. Cold water, in contrast, flows smoothly with a deeper, more mellow splash. The sound comes mostly from the water's movement and impact, not from collapsing bubbles. Next time, try listening with your eyes closed. You'll hear the temperature difference. Back in the 1700s, scientists believed in something called the Phlogiston theory. It claimed all combustible materials contained a fire-like element called phlogiston, which was released during burning. When Joseph Priestley discovered that some air made flames burn brighter, he thought he had found air without phlogiston and called it dephlogisticated air. That air, we now call it oxygen. So what was dephlogisticated water? It referred to purified water, free of impurities or substances believed to be saturated with phlogiston. It was early chemistry's way of saying ultra-pure H2O. Though the phlogiston theory was eventually disproven, the term stuck around in historical texts and journals. Water is one of the only known substances that exists naturally on Earth in all 3 states: solid, liquid, and gas. It has a neutral pH of 7 but can act as both an acid and a base. This amphoteric nature is why it's so versatile in chemical reactions. And get this, water molecules don't die. The H2O you drink today might have once flowed through a dinosaur, rained on ancient Egypt, or condensed from comet vapor millions of years ago. Astronomers have found water vapor around distant stars, moons like Europa, and even in the cold depths of interstellar clouds. In fact, the largest body of water ever discovered is a quasar 12 billion light-years away, surrounded by a cloud of water vapor containing 140 trillion times more water than Earth's oceans. That's not just mind-blowing, it's cosmic hydration on a galactic scale. So next time you take a sip of water, remember, it's not just a thirst quencher, it's a quantum-level shapeshifter, a planet-cooling miracle. a sound-bending, ice-morphing, gravity-defying oddball of the molecular world. If this blew your mind, hit like, subscribe, and share it with someone who thinks water is just water, because now you know better. And tell us in the comments, did you know water could do all of this?